All right, 4.4, we're going to look at the trigonometric functions of any angle. All right, so we've just been looking at the unit circle that has a radius of 1. Now we're going to look at, well, what happens if that circle has something other than a radius of 1? What happens is that we have something other than a radius of 1. What I tell my students is draw the picture, plot the points, and then make your right triangle and solve it. Here is a little bit of a diagram, and if you don't memorize this, if you do it the way I show you on the notes, it's no big deal. Some people like to memorize this and then they don't have to draw that stuff, whatever. Sine is y over r, where r is the radius. Does it make sense that sine is y? Yeah, because from the unit circle, sine was the y value. Cosine x over r, tangent is still y over x, reciprocals. And then r, the radius, is x squared plus y squared. Yes, I have this memorized just because of the many times that I've taught it. But you don't have to memorize it. You have enough things in your brain. How else can you do this without memorizing it? Well, let's plot this point. -2, 3. That's this point right here. So there's your radius. Well, what do you know? What is this side here? I put a -2 there because negative, I know I don't measure lengths as negatives. This negative is just giving me direction. And then going up is what? 3. That's my ordered pair. I went over 2, up 3. So that's the lengths of each one of these. How do you find, there's your right triangle. How do you find this hypotenuse here?
-2 squared plus 3 squared equals.
So that's the square root of 4 plus 3, or plus 9. So this is the square root of 13. They ask us to find sine, cosine, and tangent. Our theta is right here. Sine is opposite over hypotenuse. 3 square root 13. Does that fall true with what this says? That it's the y value over the r? Yep, y was 3. Cosine is adjacent. Okay, I used the negative. -2 square root 13. That holds true up here too. And then tangent is opposite over hypotenuse, which is 3 over -2. So tangent is opposite over hypotenuse. Now I left this negative here. In this quadrant up here, you know that the what? The cosine is negative, the sine is positive. And that's true here. If you draw your triangles, use everything you know. You don't need to memorize this. And you will always get your signs right. Here's a mnemonic way. All students take calculus. That means all functions are positive. Students, S, that means sine is positive. Tangent is positive. Cosine is positive. Everything else is negative in these three. So all students take calculus. Again, you plot those points, use the information you know about our quadrants and everything. You never have to remember all this. All right. But I'm going to give you problems like this where I'm going to give you what the sign is. You've got to figure out what quadrant it's in. Well, sine is negative, so it has to be down here or down here. All students, these are all are positive here, sine's positive here. Tangent is also what? Which means it's negative. So where's the sine and the tangent both negative? Quadrant 4. So that means that I'm down here in this quadrant. Here's my theta. Sine is negative 4 over 5. 5 is which part of this triangle? The hypotenuse. Sine is opposite over hypotenuse. So 5 is your hypotenuse. Hypotenuse is always positive. And then opposite is negative 4. Does that make sense that this opposite side is negative? And then what's this? Well, this is 3. How did I get that so fast? This is a Pythagorean theorem, but this is the 3, 4, 5 right triangle. And if you don't remember that, that's good. That's okay. This is just the hypotenuse squared minus the negative 4 squared, which is 25 minus 16, which is the square root of 9. So what's the cosine? Cosine is adjacent over hypotenuse,
3/5.
so it's 3/5. Cosecant is what? Negative 5 over 4, because sine and cosecant are reciprocals of each other. Questions on that one? All right, now, this one says let theta be an angle in quadrant 3. So we're down here in quadrant 3. Over here in quadrant 3, we know that sine and cosine are both what? Negative. They gave us the sign. They said use trig identities. So that means you're not drawing the triangle, you're using the trig identities to find cosine. Well, if I know sine, how can I find cosine? Trig identities.
Cosine squared equals 1?
Yeah. So negative 5/13 cosine squared equals 1. So what's that? 25 over 169. how did I get 144 over 169? Common denominator, and if you're doing the common denominator of 1, it's just 169 over 169. So 169 minus 25 is 144, and when I square root it, we get plus or minus 12/13. But because I'm down here in quadrant 3, I know that cosine is what? Which one of them am I going to use? The negative. So my answer here is a negative 12 over 13. Secant is a reciprocal of what? Cosine, so this is a negative 13 over 12. Tangent is what?
Sine over cosine.
Sine over cosine, which is a negative 12/13. Sine is 5/13 over negative 12/13. Which gives us 5/12. And you know down here in quadrant 3, sine and cosine are positive, which means tangent is, sine and cosine are negative, which means tangent is positive. 13s cancel. I took 5/13 multiplied by the reciprocal of the denominator. Questions? Sylvia, what's your question?
It should be negative 5/12 or no?
No, because sine and cosine are both negative. It's a negative divided by a negative is positive. We're down here in quadrant 3. All students take tangents positive. Okay, evaluate each of these angles. So I did a chart here. Evaluate sine. Yeah. Cotangent. And secant at the 4 quadrants. So at theta, pi over 2, pi, 3 pi over 2.
Why did you forget to put the theta or alpha or whatever symbol you used?
Say that again, what?
You just wanted to forget to put the symbol.
So 0 is the order pair 1, 0. This is 0, 1, negative 1, 0, and 0, negative 1. So where do I find the sign of all these?
Y.
The y's. Cotangent is what? X over y. So this is 1 over 0, which is undefined. This is 0 over 1, negative 1 over 0, and 0 over negative 1. These ordered pairs came from the unit circle. Secant is what? 1 over x. Let's take the reciprocals of x. So what's a reciprocal of 1? 1. What's a reciprocal of 0? Well, 0 is like 0 over 1. Its reciprocal is 1 over 0, which is undefined. Reciprocal of negative 1, reciprocal of 0. Okay, the next important thing here, everybody, any questions on that top chart? You could have done this a long time ago. Reference angles. Let theta be an angle in standard position. Its reference angle is the acute angle that's formed by the terminal side and the x-axis. So for example, an angle between 0 and 90, its reference angle is itself. An angle between 90 and 180, its reference angle is going to be right here. So if this was 75, what's its reference angle going to be? What?
But 75 wouldn't be itself because it's in the 90.
Oh, I'm sorry. How about 115? That's better. So what's its reference angle going to be? 65. Because I go 115, I need 65 more to get here. All right? So find the reference angle for each of the giving angles. So 218. 213. Where does 213 fall? Down here. So 213 goes here.
So it'd be 57.
So its reference angle is right here, which is 33. It's actually, it takes me to 180. I go, here's 180. So 180 plus what? So it's 213 minus 180.
Why would it be the back reference instead of going more forward? Why would it be 33 instead of 53?
Because it's the reference angle is what it makes with the x-axis.
Gotcha.
It's the angle between the terminal side and the x-axis. Okay? 1.7, now that's in radians. We got to figure out, where does 1.7 radians fall?
You just change it to degrees.
You could, but here's what I did. Pi over 2 is approximately 1.57 degrees, or 1.57 radians. So where does 1.7 radians fall? And then pi is 3.14. So 1.7 is going to be right here. So what's this reference angle going to be?
It's not that they change degrees.
You're going to take pi, this 1.7, what's it take for me to get to pi? Take pi minus 1.7. So our reference angle is approximately 1.4415 AP. $1.44. Last one. Where does a negative 144 degrees land?
A third quadrant.
Third quadrant. We're going negative. So our reference angle is this angle here. And what does theta equal? Well, that's not theta, that's beta. Because theta is that.
Negative 36.
Negative 36. Not, well, actually, we just do positive 36. It's just the angle between the two.
So that's always going to be a positive number.
Yes, it'll always be a positive number, yep. Questions there?